This video is for the Unreal Engine 4 Shaders and Effects Cookbook, chapter Advanced Material Techniques. Specifically, it's for creating a brick wall with a parallax occlusion mapping. And this one's going to be a lot of fun um, to see what comes out at the end. So parallax mapping is different than normal mapping, even though they're kind of sort of trying to do something very similar. So normal maps are really great for small surface details that shouldn't affect the silhouette because the normal map is more of like a trick versus actually changing the geometry of your object. So instead of so if you think of it like an object that has a normal map applied, if you rotate it, the silhouette is still going to look exactly the same as if it didn't have a normal map. It's just for those like fine surface things like cracks and just little blemishes in the surface, maybe like really super fine wrinkles in something, or like fabric texture. Now, a parallax on an object is different because it actually is going to displace the pixels rendered on the screen, so that if you were to look at it like from like an angle, it would be sticking out. So it does actually affect the silhouette of the object. This is done through the GPU rather than the CPU, and that's kind of an important distinction to know. So things like your 3D models are done through the CPU, like your if you think about how they're handled in a game engine, because it also takes into effect things such as like collision and stuff like that. That's handled with the CPU. The GPU is meant mostly for how things look. So you could, for instance, we're going to be doing a brick wall. If you had modeled out all of those bricks, it would have a lot of it would be a high poly model. It'd be handled by the CPU. By doing a parallax map on here, though, we're going to be handling like that extra. I don't want to say geometry because that's not the right term, but like that look of what looks like high geometry through the GPU instead. The one issue that I would like to mention with this, though, is that things such as collision are handled in the CPU, not the GPU. So if you do a parallax map that does change the shape of your object, the collision on there is not going to be following the shape of the object, since usually collision is done with the mesh. So since you're not actually changing the mesh, you're just changing the pixels on the screen to look like the mesh is changing. It could have some collision issues depending on how much you're using it. There are ways to work around that, but just kind of keep that in mind. That's something that if you are unaware of and you encounter it when you're building an environment with with a parallax, it can affect things. So we are going to be creating a brick wall. So, this is like the default. And so just make sure you're starting in the correct chapter. And the first thing we're going to do is we're going to create a material to put on this wall called M underscore walls underscore parallax. And let's make sure that we do apply it to our wall too. So I'm going to select that wall and I'm going to put it into element 1 so that it changes to that. We're kind of keeping the camera over here so that we'll be able to kind of see it better when it starts working. So let me open this up. And the first thing we can do real quick if we want to, and this is, we're going to use this later on, but I kind of want to be able to take a look at this, is I'm going to put a texture, I'm going to set up my texture samples first, and it's a little bit different than the book, just because I do want to be able to see what it looks like before and what it looks like after. I think that'll be a really neat way to kind of show how this works. So I'm going to actually do 3 texture samples. So 1, holding down T and clicking, 2 and 3. And this first texture sample, I'm going to change the color to, it is T underscore wall, and just use the T wall's depth for this one. It is a grayscale image, and that's fine. Don't use, if you want to follow along with what the book does, it uses this one. And this one, the second one is going to be a T underscore walls, and it's the AORM map, our texture. And then this last one is going to be for our normal map, so that's T underscore walls, and find the normal. So we can hook this all up. So RG, this one goes to base color. The AORM, the R goes to ambient occlusion, and the G goes to roughness. There's no metallic map since there's no metal on this. And then this will go into our normal map. So if we apply and save, and we take a look, we can see what we get with this. And don't worry about the tiling, but the big thing is if we go like this, you see that like it's perfectly flat, but we are getting like kind of a hint that it does have some depth to it because of that normal map, but normal maps can't actually change it. So I'm going to take a real quick snip of this wall so that we can refer to it later after we get the rest done. And you know, there's nothing necessarily wrong with this. Like you just working with a normal map, a lot of times, you know, depending on the game, like that might be good enough. But if you do want to kind of play around with parallax mapping, it can be really fun to work with some of these. And it's, you know, definitely a much more advanced look to it. So let's set up that parallax stuff. So we can keep this as is. We don't need to change this. What we are going to do is we are going to find a node called the Parallax Occlusion Mapping node. And we can do that by right-clicking and start typing Parallax Occlusion Mapping. In the book, it starts referring this as the POM for Parallax Occlusion Mapping. So if I say POM, or you see that written, it's just referring to this node right here with all of these fun things that we got. We don't have to do all of them, but we're gonna stick a bunch of work with this. So let's see. The first thing we need to do is we need to make a texture object node, and that's different than the texture sample node. This specifically wants a texture object node because we need it for here. So it's a little bit different. And the easiest way to find this is going to be to pull a wire from here and search for texture object. And it's this one right here, this texture object. And, you know, texture object, not texture sample. So they're different. Notice that there's like differences even to their output. So we do want to put in here our, not this default one, but our T underscore walls, this depth map, which again is just a grayscale image where white is fully out, dark is pushed in, and that's what's going to help drive our stuff, our parallax stuff. Okay, so we have that. The next is going to be manipulating the height ratio. And this is going to affect how much of our texture extrudes and intrudes based on this. So this is probably something you want to make as a scalar parameter. And you can always, you know, tweak it. It's something you might want to kind of play around with and see what happens. So I'm going to call this height ratio. And we're going to give it a height ratio value of 0.02. So it's not very big. So keep that in mind, 0.02. And we are going to connect this to, no surprise, the height ratio input. So the next one is going to be the min steps. And this is going to help us control kind of like the quality of this. So we need another scalar parameter called height steps. And what I would recommend I'm sorry, min steps, not height steps, min steps. What I would recommend after you get this all done is to come in and tweak these values while you're looking at it and see how it changes things. And you're going to learn a lot about like how to set things up, what these all do, what all these settings are by having that, and you'll really understand the setup better. So the min steps, we're going to set that at 8 and connect that into min steps. We're going to need another one for max steps. So let me move these up. We're not going to quite hook up max steps yet. There's another one that we need to, there's some more stuff that needs to go with there, but ultimately this scalar parameter is what's going to be controlling it. So we are going to call it max steps, but we need a couple other nodes first. So this one's going to go over here. Stuff will eventually be hooked up into there, and this is what's going to kind of drive that one. So the next one we need, we're going to kind of move it down this way, is another scalar parameter that we are going to name Temporal AA Multiplier. And what all of these are for, and let's set this to 2, is kind of controlling, again, how nice, how smooth our how nice our parallax looks by adding like extra levels of detail to it. So again, come play with these when you're done with this so you can see what tweaks to them, what happens to your materials. Okay. So we're going to create a lerp. So I'm going to hold L and click. I'm going to feed this actually into the B slot. And we're going to leave A at 0. So we don't need to mess with that. That's fine. This just gets fed into B. The next step is going to be to add something for the alpha. And we are going to create a node, I'm going to right click, called Dither Temporal AA. And dithering is a concept, if you might have seen it. In fact, let me pull up an example of dithering so you can see it. It's a way to kind of, if you don't have a lot of resolution, it's used in like really efficient graphics where, if it's used a lot in like grayscale imagery where just this, it has like grayscale where it's basically black and white dots, and based on the pattern that they're put in, you can kind of show shading and gradient just solely based on dots. So dithering is like a very old school way of getting shading done with literally just black and white. You can do dithering also with color. This is very common when you do print. So like print media, like if you think of like newspapers and stuff, they do dithering patterns. So this dithering temporal AA will give us some dithering so that we can kind of feed this. We're going to feed this actually into the alpha, and you can kind of see what it looks like over here, like that dithering. Actually, let me see if I can. I don't know if you can see that very well, but it's got like a very fine grained pattern to it, that dithering, and it's going to kind of help us. We're going to be able to use this to kind of smooth out our parallaxing, so it's not just like really hard looking. So it's kind of like a nice way to make things look smoother. So we got that. The next step is we're going to create a multiply now. So I'm going to kind of move this over to here. Sorry, just hold M and click and feed the max steps into here and this lerp into here. And we can then hook this now into here. And while we're at it, I know we forgot to set max steps. This is, again, another thing to kind of play around with. Let's set it to 32. So we got all that, and we need to work on one more little part. Two more little parts, I'm sorry. We are going to create a vector parameter. So I'm going to just type vector parameter. And we're going to call this channel. We are then going to give it a value of red. So if we select this over here, we're just going to give that R a value of 1. And we need to then make an append node. So I'm going to click here, add append, this append vector. And this is something that's wrong in the book. The image is right in the book. The writing is wrong in the book. You need to feed this, this into here, not the red channel like it tells you to. And then you need to feed this the alpha channel into here so that we have a vector, a float 4 coming out of here, rather than a float 3. Like, we need to make sure that we're getting the correct thing out of here, because this height map channel here needs a vector 4. So we're going to feed this directly into here. So finally, the last thing we need to create is this UV, a thing for this UVs right here. So let me kind of move this out of the way. We are going to create a texture coordinate node. So right click, texture coordinate. We're going to keep it set to what it's set to, that's fine. We are going to add another scalar parameter. And we're going to use this to affect the tiling of our wall. So normally you take care of this through another means, but the way that these POMs work or POMs work is you do have to control it this way instead. So we're going to just call this tiling. And we're going to set it to 7. So again, here's another area where you could try to play around with these parameters and see how they affect this. So we are going to then create a multiply node to put these together. And then we are going to feed it into our UVs. So that just connects up into there. So double check that you did connect everything correctly. And again, this one is different than the text in the book, but it does match the picture in the book. So just be aware of that. So we're done with this side. We do have to hook some things up now on this side so that we can get stuff out. Specifically, what we need to do is we need to take this Parallax UVs and we need to hook them up into our textures over here so that we're getting those Parallax UVs. And you can already see a difference in there. If we zoom in, do you see how it's tiling now? And we just got to get the rest of those hooked up too. So we'll get the UVs. And we will hook this also into the UVs. So we're almost there. We do need to make a slight change to still get that working correctly. We do need to do a pixel depth offset on here, because remember, we are like moving our pixels around. So this pixel depth offset hooks up to this pixel depth offset. So I'm going to connect this up. And we need to still do a couple of tweaks to our normal map. So go to the normal map right here. And we are going to change the MIP value mode from none. We are going to change this to derivative. So down here. And it's going to throw an error, and that's fine because we can fix this. We need to give it a ddx and ddy value in order for this to work. So we are just going to right click and search for ddx and place one of these nodes, and then a ddy, place one of those nodes. We can hook those up. Oops. And we got to still give these values, and what we do is these get hooked up to this multiply right here. So that texture, this multiply over here, we're going to just feed those over here. And that should take care of all those errors. And we can really see this happening here now. And that should be it. So it should look something like this. And it's getting a little bit big. See if I can help a little bit if you are trying to just do a quick glance to see. So these are kind of hooked up to there and our UVs. So maybe this will squish this up some. I'm trying to give you like a final look where we can see the most of it at the same time. Okay, there we go. All right, let's apply and save this. And take a look. So let's check. I'm surprised it's still flat, but I guess because there's nothing sticking out on the outside, but you can see the difference here between it going in. Do you see that? Like, we can actually see it getting pushed in right there. So like if we go like this, it actually looks like there is geometry there. So like let's look at the comparison screenshot with this. So that's the original. And the big thing, do you see how the lighting is actually affecting things? Like we're getting like that nice shadow in there. It actually looks like it has depth to it because it is affecting those pixels. So again, this is controlled by your GPU. It's not controlled by the CPU. So if we were to like collide with the wall, if this was sticking out or pushing in, it's still going to be where that original mesh is. So there are ways to handle that. But hopefully you've gotten this to work and you can start experimenting around with some of those settings. Back in the material, all these scalar parameters, play with them, see what they do, and have some fun with it.